All right, we are getting ready to record our first session for Survey of Contemporary Mathematics. This week in your apply assignment, you're going to be learning chapters 1, 2, and 3. It's quite a bit of information. Hopefully, as we go through these examples, you'll find yourself remembering how to do a lot of this basic math. But as we go through here, it is a lot, and I'm going to try to get it in our time. But don't hesitate to speak up and stop me if you've got some specific questions. At the end of our recording, I will also stay on if you have some additional questions that I can answer for you. So we're going to begin with some definitions and examples to help us review these first 3 chapters. So remember that exponents tell us how many of that base number or variable that we have. In this first example, we have x to the 5th power. 5 is my exponent. That 5 tells me that we have 5 of the base x. So if I were to break that down, that would be x times x times x times x. So I have 5 x's that are multiplied together. So this is a way to write our answer exponentially and in a more compound way. Of course, here there's nothing else to evaluate, but when that base is a number and we're asked to evaluate that, that would be the same as 4 times 4 times 4. And of course, you can use a calculator, but we get that answer because 4 times 4 is 16, and then 16 times 4 would give us 64. If you are asked to write an answer in your Excel document, if the answer were to be written as 4 to the 3rd power, there is a caret key on your keyboard, which is right above the number 6. So you would write 4 and then type in that caret key to the 3rd power. If you were giving an answer exponentially, it would look like that. This would be how you would input that into the Excel document if you were leaving your answer with exponents. If you're asked to evaluate it, this is how we would do that. So 2 to the 4th power is 2 times 2 times 2 times 2, and we can multiply 2 numbers at a time. 2 times 2 is 4, 2 times 2 is 4, and then 4 times 4 would be 16. So that's what exponents do. They tell us how many of that base value that we have. And we need to know how to work with exponents because we see that when we work a problem that requires the order of operations. You may remember PEMDAS from school. Please excuse my dear Aunt Sally. That is the order that we work problems that contain multiple operations. So you will begin by working with parentheses or any grouping symbols. If a problem contains more than one grouping symbol, then you would start with the innermost one and work your way out. Then you'll work with exponents. Next is multiply or divide from left to right, whichever comes first. And then last, you'll add or subtract from left to right, whichever comes first. So I have an example for us that will require us to use the order of operations. So we're just going to go down that list. Do we have a parentheses or grouping symbols? Yes, I see that here. That is 8 minus 4, and that would equal 4. And then the next thing we're going to do is work the parts that involve exponents. So 4 squared is 4 times itself. 4 times 4 is 16. And then here I have 5 squared, which is 5 times 5, or 25. All right, so now I'm going to bring down the remaining numbers and operations that I have not yet used. Next, we're going to go on to multiplication or division. We'll work whichever comes first from left to right. So as I work across here, I see division and multiplication. So I've got to work left to right. 64 divided by 16 is 4. And then I can multiply 4 times 9 to get 36. And then last, we add or subtract whichever comes first from left to right. So 36 minus 25 would give us an answer of 11. So you'll want to just really review that order of operations, PEMDAS, parentheses, exponents, multiply or divide, add or subtract. That'll help you as you work problems that have more than one operation. And I'm very sure that you will see a problem requiring that on your apply assignment this week. So just take the time to check that you follow those operations carefully. Once again, if you have any questions as we go through this material, feel free to unmute yourself and chime in. Okay, this next example involves factors. In example 3, it asked me to list all the factors of 60. So a factor is any number that will divide evenly into that given number. So I want to know what numbers divide into 60 evenly. And what I like to do is just start with the obvious pair. 1 times 60 is how we get 60 in the first place. So any number times 1 will be a factor pair. And then from there, I'm just going to count until I get as far as I can go. I know because this is an even number, it ends in an even number, so 60 is even, and that means 2 will divide in. So 2 times 30 is 60. Next, I'll try 3. 3 goes into 60 20 times. I know that 4 will divide evenly into 60 15 times. You can use your calculator to test these values. There are also some tests for divisibility. You can look that up and just kind of see all the different ways to use those tests for divisibilities to find out all the whole number factors of a number. It ends in 0, so I know that 5 goes in. 5 times 12 is 60. And what's happening as I'm writing it this way is I'm working towards that middle number, and once I get once I get there, I know I'll be able to stop. And 5 times 12, 6 times 10 is 60. 7 will not go in, nor will 8, nor will 9. So I'm already down to 10. So that gives me all of the factors of 60. So you may be asked to list all of those factors. Make sure to include all the numbers that will divide evenly into that number. Okay. All right, a couple other definitions are prime numbers and composite numbers. Prime numbers are numbers that are only divisible by 1 in themselves. So some examples of that are 2, 3, 5, 7, 11, 13, 17, 23, and so on. These numbers are only divisible by 1 in themselves. Notice 1 is not a prime number because 1 only has 1 factor, which is itself. But all of these prime numbers have 2 factors. 2 times 1 is 2. 3 times 1 is 3. So prime numbers have 2 factors, 1 in themselves. Whereas composite numbers are numbers that have more than 2 factors. 4 is 1 times 4 and 2 times 2. 6 is 1 times 6 and 2 times 3. So these are some examples of composite numbers. Notice up here that 2 is the only even number that's prime. But that doesn't mean all of the odd numbers are prime, because 9 is odd, and it's composite because not only is it divisible by 1 and 9, but it's also divisible by 3. Okay, but definitely all of the even numbers besides 2 are composite because 2 will go into any other even number. But notice some of the odd numbers are also composite. So be familiar with those. We need to know what prime numbers are because we will be asked to find the prime factorization of a number. And these this is a way to factor a number down to only its prime numbers. And we typically use a factor tree to do that. So I'm going to take that same number that we just used in our last example. Notice here I listed all the factors of 60. That includes some prime and some composite. Those were all the numbers that will divide evenly into 60. But if I want to find the prime factorization of 60, I want to know what are the prime numbers that multiply together to be 60. So I'm going to do a factor tree. And when we start a factor tree, I can start with any 2 numbers that multiply to be 60. You can do 6 and 10, 2 and 30, 5 and 12. You can start with any of those pairs that we mentioned before. But we will not stop until we only have prime numbers. 6 is not prime. It can be factored down to 2 times 3. 10 is not prime. It can be factored down to 2 times 5. So now what I have is a row of all prime numbers. If I were to multiply 2 times 3 times 2 times 5, then I get 60. Okay, so the prime factorization, I typically put these in order numerically, though you would not get deducted points if you don't, unless it asks you to do that. So be sure to read those directions carefully. So that would be 2 times 2 times 3 times 4. Remember this, this is also a symbol for multiplication that I sometimes use. We rarely use this in algebra because it kind of looks like the variable x. So just be careful to use a true multiplication sign or this symbol here for multiplying. If your problem asks you to use exponents to write any repeating numbers, since that is 2 times 2, there's 2 2's, you could write that as 2 squared times 3 to the 5th power if it were to ask you to use exponents to write down any of those repeating values. So do know the difference between listing all the factors of a number versus the prime factorization of a number, because all of these numbers don't multiply to be 60, but there are factor pairs that do multiply to be 60, okay? But this prime factorization will multiply together to give you your number 60. So just reread those definitions and make sure you could do a problem like either of those. Okay, our next example is actually going into chapter 2 where we're asked to find the least common multiple. Now what this is the smallest number that a given set of numbers divides into. Don't confuse factoring with multiples. I am not looking for a number that divides into 24 and 36. I'm looking for a number that 24 and 36 will divide evenly into. And one way to find the least common multiple is to, hang on just one second. Let me see who's joined us. Okay. Tammy, I'm going to mute you right quick while I'm recording, but you are welcome to unmute yourself if you have any questions throughout the recording. So I want to find a number that 24 and 36 will both divide into. That's why we call it the least common multiple. So one way to do this is to take each of those numbers and to just begin listing multiples. 24 times 1 is 24. 24 times 2 would be 48. 24 times 3 is 72. And I can just keep going on endlessly. 36 times 1 is 36. 36 times 2 is 72. And I can stop there because I have the smallest multiple that they have in common. That's what we call the least common multiple. It's the smallest number that 24 will divide into and that 36 will divide into. 24 times 3 is 72, and 36 times 2 is 72. Least common multiple. All right. A different note here is greatest common factor. This is the largest number that divides into a given set of numbers. So I'm using the same set of numbers, 24 and 36 again, because I want you to truly know the difference between a greatest common factor and a least common multiple. 72 is divisible by 24 and 36. But what is the largest number that will divide evenly into 24 and 36? There's a couple of ways I can do this. One of the ways is just listing all the multiples of each of those numbers like I did in example 3 here, where I list all of the factors. Another way to do that is to find the prime factorization of that number. I'll work both methods so you can decide which way you prefer. But I know that 24 is 1 times 24. It is 2 times 12, 3 times 8, 4, 6, and 5 won't go in. So those are all the factors of 24. 36 is 1 times 36. 2 times 18, 3 times 12, 4 and 9, and then 6 times 6. So those are all the factors of 36. I could go through here and I can see all the common factors that they have. But the greatest common factor would be 12. That's the largest number that divides evenly into 24 and 36. Okay, so if you understand that method, that's perfectly fine to find the greatest common factor. Another way to do that is by finding the prime factorization of each of those numbers. So like 24 is 3 times 8. 3 is prime, but 8 is not, so I'm going to keep factoring. That's 2 times 4. 2 is prime. I'm going to keep factoring 4. That's 2 times 2. Okay, so that's the prime factorization of 24. 36 is 6 times 6, which is 2 times 3 and 2 times 3. So to find the greatest common factor of these numbers, I would want to find what prime factors do they have in common. Notice this one has 2 2s, so I can highlight 2 2s over here. And this has just 1 3, so I need to highlight just 1 3 over here. What they have in common. Each of them are divisible by 2, 2, and 3. Well, 2 times 2 times 3 is 4 times 3, or 12. So either way, whether you list all the factors or do the prime factorization with a factor tree, we can see that the greatest common factor is 12. Okay, moving along. Next, we're going to study some about fractions. The definition for an improper fraction, it is a fraction whose numerator is larger than the denominator. That means the number on top is bigger than the number on the bottom. So the larger number is in the numerator, the denominator is smaller. Here are some examples of improper fraction, 12/7 and 7/3. And in this example, it asked me to write each improper fraction as a mixed number. So to do that, I'm going to take the numerator and divide it by the denominator. 7 will divide into 12 one time, and if I subtract, I have a remainder of 5. So we would write that as 1 5/7. 1 is my whole number. That remainder is the numerator, and the number that was originally in my denominator will stay in that denominator. So 12/7 is the same as 1 5/7. I'll do the same with this example. 7 divided by 3. 3 will divide into 7 twice. And then I have a remainder of 1. So that is 2 1/3. So be able to take an improper fraction and write it as a mixed number. Even though these are equivalent to each other, you'll want to pay attention as you work through your apply assignment this week to give the answer specifically as it asks. So if it wants you to leave it as an improper fraction, be able to do that. If it says to simplify it and convert it to a mixed number, you'll also want to do that as well. These answers are the problems in example 4, because I'm going to show you now how to go from a mixed number back to these improper fractions. So to convert a mixed number to an improper fraction, you're going to take your denominator and multiply it times that whole number. 7 times 1 is 7. And then you will add that numerator. So 7 times 1 is 7, plus 5 is how we get 12/7. This is an important step to learn how to do, because in just a little bit we're going to be multiplying and dividing with mixed numbers, and this will be a step that we have to do in order to multiply and divide those fractions. So let me do that example one more time. 3 times 2 is 6, plus 1 is 7, and you keep the same denominator. So 2 1/3 is the same as 7/3. So be able to go from an improper fraction to a mixed number, and then from a mixed number to an improper fraction. Okay, next we're going to look at equivalent fractions. We can get equivalent fractions by multiplying by 1. We know that we could multiply anything times 1 and we get that same number because, you know, 1 is like the multiplicative identity. I could multiply by 1 and I get that same number. It's identity. But 1 comes in a lot of forms. 7 over 7 is 1. 2 over 2 is 1. 11 over 11 is 1. So it's possible that I might need to multiply by any of these versions of 1 to get an equivalent fraction. So in this example, I have 5/8, and I want to know what fraction is it equal to if I change the denominator to 32. So 5/8 is equal to how much over 32? Well, the thing about multiplying a fraction, I have to multiply the numerator and the denominator by the same amount in order to get an equivalent fraction. I know that 8 times 4 is 32. So if I multiply 5 times 4, that will give me 20. So 5/8 is equivalent to 20 over 32. In the same way here, I know that 3 times 6 is 18. So 2 times 6 will give me 12. 2/3 is equivalent to 12/18. So I just want to find an equivalent fraction and to solve for that missing portion of that equal fraction. In order to add or subtract fractions, you must have a common denominator. This is a common mistake with students. They'll just want to add the tops and add the bottoms, but this is not 10 over 20. You cannot add these the way they are. So you're going to have to find a common denominator. The same way we found least common multiple just a little while ago, we're going to need to find a common denominator in that way. So I'm going to take 8 and 12, and I'm going to see what that common multiple is. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. I can keep going, but I know 12 times 1 is 12, and 12 times 2 is 24. So there is my common denominator. So 3/8 is equal to how many 24ths? Well, I know that 8 times 3 is 24. So 3 times 3 would be 9. 3/8 is equivalent to 9 over 24. Okay, next I have 7/12. How many 24ths is that? So 12 times 2 is 24. So 7 times 2 would be 14. 7/12 is equal to 14 over 24. Now notice this operation was addition. You'll follow the operation whether it's adding or subtracting. This one tells me to add 9 24ths plus 14 24ths. And when I do that, I will only add the numerator. The denominator stays the same. So 9 plus 14 is 23. So my answer is 23 over 24. Must have a common denominator in order to add or subtract with those fractions. Okay, next thing we're going to do is practice multiplying and dividing with fractions. When you have mixed numbers, when you're multiplying with mixed numbers, you will first have to turn them into improper fractions. If this was, I'm just going to take 1/3 times 7/8 first. If they're just regular fractions, you do not have to have a common denominator. You would multiply the top and multiply the bottom, okay? That's how we work normally multiplying with fractions. But these are mixed numbers. So the first thing I'm going to have to do is convert them into improper fractions. Remember how we did that before. 3 times 2 is 6, plus 1 is 7/3. 8 times 3 is 24, plus 7 is 31/8. So convert those into improper fractions. Then you're going to multiply the numerator. 7 times 31 is 217, and 3 times 8 is 24. Now that is the correct answer. It is an improper fraction, and if your problem asks you to leave it as an improper fraction, you would stop there. If the problem asks you to give that as a mixed number, then you would have to divide the numerator by the denominator. You can use your calculator to help you out here, but I know that 24 will go into 217 9 times. 9 times 24 is 216, and that gives me a remainder of 1. So this is equivalent to 9 and 1 over 24. So these are equal. Just make sure you give your answer in whatever form it asks for. If it's not specific, then I can accept either answer. Now, when we divide fractions, we will instead multiply by the reciprocal. I like to call this leave, change, flip. So in this problem, I have 5/6 divided by 5/12. We really can't divide the fractions as they are. Instead, we're going to leave the first fraction alone, change division to multiplication, and flip that second fraction. We are multiplying by the reciprocal. Reciprocals just flip numbers around. 5/12 reciprocal is 12/5. So we're going to leave, change, flip, multiply by the reciprocal. We'll multiply the numerators. 5 times 12 is 60. 6 times 5 is 30. And 60 divided by 30 would simplify down to 2. So you'll want to reduce as far as you can, but make sure to follow those operations correctly. Okay? A lot of information. We still have one final chapter to look at, and chapter 3 mainly deals with decimals. So I want to just briefly go over those rules for adding, subtracting, and multiplying and dividing with decimals. So number 1, you must line up the decimal point when you're adding or subtracting decimal numbers. Of course, you've got a calculator. You can lean on that to check your work. But if we're adding, we are going to line up the decimal, not necessarily the digits. If you have any open spaces, you can fill those in with zeros, and you're just going to add the place values one at a time, bring that decimal straight down. So 163 thousandths would be the answer to this question. All right, when I'm subtracting, these are the same numbers. I'm going to subtract them this time. I'm going to line up those decimals. I'll fill in any spots with 0, and now we just subtract. Don't forget, you may have to borrow occasionally. 12 minus 4 would be 8. That 0 must come down, and then my decimal. That's very important to put that 0 in that 10th spot because there's no number to represent that place. So this answer is 83 thousandths. When you're multiplying decimal numbers, now you're going to multiply the numbers like you normally would, and then count how many numbers are behind the decimal. You will put that amount of numbers behind the decimal in your answer. So don't be confused by those decimal places. You could multiply this just as if it was 123 times 4. That would be 12. 4 times 2 is 8, plus 1 is 9, and 4 times 1 is 4. But now I've got to decide, where does my decimal go? When we add or subtract, we just bring that decimal straight down, but that's not the case here. You do not have to line up the decimal point when you multiply. So I've got to count. There are 1, 2, 3, 4, 5 numbers behind the decimal. So I have to put 1, 2, 3, 4, 5 numbers behind that decimal. It was very important that I add these zeros between 492 and my decimal point. I could not just drop a decimal here and add zeros at the end, because those zeros can actually just fall off. That's not the same number. So I got 492 when I multiplied, but because there were 5 numbers behind the decimal, starting from the right, working my way to the left, I have to put 5 numbers behind the decimal. So that's tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this decimal is 492 hundred thousandths. Be able to read that properly or write that down properly if asked to give it in that way. Okay. One final rule with decimals: you actually can't divide by a decimal. So you're going to have to take the divisor's decimal point and move it until you get a whole number, and then move the dividend's decimal over that same amount of spaces. When you have a number written like this, the first number goes inside that box. Okay. I cannot divide by a decimal, so I'm going to shift that over 2 spaces until I get a whole number. That'll now be 4. But I have to take the dividend's decimal and shift it over the same amount of spaces. So what I have now is really 12.3, divided by 4. Now that my divisor is a whole number, I'll bring that decimal straight up. 4 will not go into 1, but it goes into 12 3 times. I'll bring that 3 down. 4 will not divide into 3. So I'm going to need to add a 0 and bring that 0 down. So 4 divides into 30 7 times at 28. I'll subtract. Got a 2. I'm just going to keep bringing that 0 down until I can't divide anymore. 4 will go into 25 times, and now I have a remainder of 0. So that answer is 3.075, or that's read 3 and 75 thousandths. Your decimal place goes tenths, hundredths, thousandths, and that ends in a THS, thousandths. So and separates the whole part from your decimal part, 3 and 75 thousandths. So you may want to refresh your memory on those decimal place values. I do have some extra practice, just some other examples that I would like to work with you, because you're going to see some of these kinds of problems on your apply as well. And I just want to provide enough information so that you feel comfortable working all 3 chapters this week. So if you can hang in there with me for just a few more minutes, I will finish up my recording, and then I can go over any specific questions that you have. For those that will be watching this video at a later date, our code word is exponents. So if you can send me a brief summary of the video and include that code word exponents, you can receive the extra credit as well. You will be asked to give a number in expanded form. That's where we break these numbers down by their place value. 4 is in the 100,000 spot, so that would be 400,000. 3 is in the 10,000 spot, so that value is 30,000. 2 is in the 1,000 spot, so that is 2,000. 9 is in the 100 spot, so that value is 900. 6 is in the tens place, so that value is 60. And 7 is in the 1 spot, so that value is 7. So this is how we would break a number down into expanded form. Notice those are separated by plus signs, because if I were to take all these numbers and add them back up, I would get the original number given to me. Rounding is an important part that I feel the need to review, because you're going to have to round from chapter 1 until the end of this course. So please review rounding. I will deduct a point if your answer is rounded incorrectly. So know your place value. Ones, tens, hundreds, thousands, 10,000s. This asks me to round to the nearest hundred spot. So recognize the number in that spot, but then you have to look at the number directly behind it. If it's 5 or more, we will bump up the score. That 6 will round up to a 7. But if it's 4 or less, we're going to let that rest at 6. We would never round that down to a 5. Ultimately, I want to know, is this closer to 54,600 or 54,700? And because 2 is less than 5, this would round to 54,600. Okay, this is the same number. Now it's asking to round to the thousand place. Okay, so 4 is in the thousands place, but I have to look at the number directly behind it. 5 or more, bump up the score. 4 or less, let it rest. Is this closer to 54,000 or 55,000? Because 6 is 5 or more, it's going to bump up that score, and this will round up to 55,000. So make sure you're rounding to that specific place. Notice everything after that position is just zeros. Okay, decimals we round in that same way. I want to round to the nearest hundredth place. With decimals, it goes tenths, hundredths, thousandths, 10,000. So 9 is in the hundredths place, but I have to look at the number directly behind it to decide, does it stay a 9 or does it round up to a 10? 5 or more bumps up the score. So this 9 will actually round to a 10, pushing that 1 into the tens place ultimately. So that will be closer to 1 than it would be 9. And so that or 1/10 instead of 900. So that is 0.10. Even though this is not necessary, it did say round to the nearest hundredth, so I want to show the hundredth spot. Okay, just a couple more. If I am squaring or cubing or raising a fraction to a certain power, I can write that down 3 times. 2/3 to the 3rd power is 2/3 times 2/3 times 2/3. So when we multiply fractions, 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. So that would be my final answer. You just raise the numerator to that power and the denominator to that power. And then final one, I think I got a typo here. I think that's meant to be thousandths. Okay. So write 5 and 900 for 10,000ths in standard form. So first of all, I see that word and. Remember, that separates my whole part from my decimal part. So I've got 904, but it's got to go out to the 10,000ths spot. If I just started here, that would be tenths, hundredths, thousandths. I need one more spot to get the 10/100 thousandths. So I'm going to put that placeholder 0 there. That's very important. That's tenths, hundredths, thousandths, 10,000 spot. So the and separates the whole part from the decimal part. 5 and 904, but it's in the 10,000th spot. So I've got to make sure I show that many decimal places. All right, so I'm going to end our recording for right now. Thank you, everyone that was able to participate with us live.